Today I have this crazy idea about implementing a octopus kind of creature, and I'm not exactly sure how this is gonna go, but I have some ideas. I was looking at these projects I did during the coding ultramarathon, and some of these things like this pendulum here, maybe even this flag here, somehow remind me a little bit of some kind of tentacles or some kind of things that move a little bit like a tentacle. So I'm thinking that maybe I'm going to base it on something like this. I don't know if it's gonna work or not. Other idea is related to this Master Skier game. Basically there we have this kind of character that you can control using these keys, but actually it works with this kind of skeleton system there, where you're moving some of the tendons of the body. And this is another way that I'm thinking maybe we can do this tentacles to be kind of like skeletons, like have this kind of skeleton with many different joints, like making a long kind of limb and trying to control that in some way. So hello. Yes, hello, dark cheese and Mare. Yes, of course. I don't know yet how this is going to look like, or how this is going to work, but basically I'm gonna try to do something using these techniques, and let's see how it goes. I'm going to code everything from scratch, so this is gonna take a while. And yeah, I have this empty box here, empty page here, and empty text file here. And yeah, I think I'll begin. I just need a little bit of energy drink. And maybe today, because I'm gonna do more of this intense coding, yeah, maybe I'm gonna need to have this kind of more serious mode on, so it's gonna get intense today. Yeah, let's see how intense mode is going to go. Yes, this is related to Santa and his penguins. So this kind of creature is going to be the main enemy of the penguins on their way to meet Santa. And I just want to focus on this character now. Basically, I want to get it as interesting as possible, and I want to code it. I don't want to have sprites for this character. So maybe I want to have it interact in some more special kind of way. But I don't know how great it's gonna go. So let's see what comes up and what you think about it. And maybe I'm gonna change whatever you think makes it look better. So let's see. So simple HTML file, empty HTML file at the moment, with head section and body section. And I'm going to use a canvas to animate all the stuff. So let's make a canvas here with ID equal to my canvas. Yeah, some weird settings on my computer. And yeah, I think that's fine. Let's have a function here when the body loads. Like this. And in the head, I think that I don't need necessarily too many styles. Maybe just let's debug the styles for this page and have a background color for the canvas just to make sure we are aligning it properly. So I'm gonna say the canvas background, let's make it blue. And the script, maybe I don't want to keep it here. I'm gonna make a new file for the script. It's gonna be a lot of JavaScript today. So I'm going to put it in a separate file, because if I write it here, then everything is going to be indented like this 3 times. And I don't want my code to get out of the screen somehow. So let's see. I'm gonna name it main.js, and I have to create this file. So yeah, okay, so now this is the empty file. Let's see what we have so far. So I'm gonna refresh and I see my canvas here, but it's not stretching on the full screen. So let's do that in our main function. I'm gonna initialize my canvas. I'm gonna get the reference of my canvas from HTML, and I'm gonna say that I want to resize it to the size of the window. So I think something like this should work. Yeah, let's test it out. Okay, it goes on the full screen now, but there are these scroll bars that are appearing at the bottom, and there is this small white area here that I want to eliminate. I'm gonna go back to my HTML and modify the style for the body to have no margin. This is gonna remove these things around here, and now my canvas is basically filling the full size of the screen. Okay, so to make this creature, I'm going to actually use particle physics, and I'm gonna try to implement a basic physics engine that is going to move these kind of joints that the octopus has somehow according to the laws of physics. Not too realistic, but as realistic as I can get it today. So I'm gonna start coding basically a physics engine, and I'm gonna try to start with the particle object, a particle class, and then I'm gonna connect particles using some kind of segments or links, however you want to call them, and they should somehow move like you would expect if we are going to impose on them things like gravity or friction, or if they collide or touch some other properties. So let's see how this is going to go. My particle class is going to have a constructor, And I'm gonna initialize this particle at a given location. So let's say that it gets the location as a parameter here, and its value is going to be stored inside this particle as an attribute of any instance we define from this class. So I'm going to say this location is equal to location. Maybe I'm going to shorten this a little bit. Seems like it's the word is recognized, so it could be something like important keyword in JavaScript, and I don't want to misuse it by mistake. Okay, so the particle is now constructed. It needs to be displayed somehow. Maybe we are not going to display these particles at the end. They are just going to be part of the creature, but I want to debug as I am coding this, and I am going to show them as small dots on the screen. So let's have a draw method, and I'm going to draw on the canvas context. Maybe I'm going to have this as a global variable as well here, and I'm going to say the context is equal to get the 2D context of the global canvas. The fire is red because today I'm serious and I'm going to do a lot of coding. So that's why it's red. Yes, now drawing, I'm going to keep this as a global variable. It's going to be the only context that we are dealing with, I think, at least today. I don't really like using global variables, but let's see if we need to parameterize everything here. So I'm going to draw this by using context methods available in the canvas context. And for example, begin path, this tells that I'm going to start a new drawing, and then I'm going to use the arc method at this location. So at the X component of this location and the Y component of this location, I'm going to make an arc with the given radius. Let's say that the radius is going to be okay, my keyboard is not really listening to me. Okay, 4 pixels or so. And then at the location, a small circle, that means that I have to start at 0 degrees and go to pi times 2 radians. So this is going to draw our full circle here. And I'm going to stroke this particle. Let's test if I can draw a particle on the canvas. I'm going to try let P equals a new particle at the center of the canvas. So let's put here our location as half its width and half its height. So initializing this particle, but if we don't draw it, we will not be able to see it. So I also have to call the draw method of this particle class here. Now, if I go back to my main page here, I see a small dot appearing in the middle of the screen. Maybe I actually use here fill so that it's more visible. And let me remove this blue background, or maybe I'm gonna make it a light blue color, kind of like like you expect water to be. So let's have this, for example, maybe something like that. Okay, it became purple. Yeah, I think I'm happy with this. And let's save the main function so that I see my filled particle at this stage. Great. Okay, but this is not doing many things here. It's just drawing a dot on the screen, basically. So what I need to do is start animating things and controlling these particles, for example, using gravity. Let's see how this will go. I'm going to start animating by calling a function called animate. And this function is going to call request animation frame. So this method here is going to try to reload the page, redraw everything on the page as fast as it can. It aims to do it 60 frames per second. And I need to give it a callback function here, this same function here. So you can think about this as a recursive call to itself, but it actually waits a few milliseconds before doing it. So now in this animate here, we can actually draw whatever our scene is going to look like. So this is now the function that we are going to have to implement for drawing on every scene. Let's see how we do that. Well, we need to have something to draw. So I'm going to make an array of particles here. And I'm going to initialize it with nothing here. But inside the main class, I'm going to add a few particle elements into it. So for example, I'm going to say here particles push, this P particle that we just created. I don't want to draw this anymore because I have now my draw scene function here. So let's go into the draw scene and loop through all particles that may be in this global variable. And draw all of them. So there is only one at the moment, but just to test if this is working, I'm going to create a few more. Let's just copy this code for the moment and say here, maybe instead of at 50% of the width, I'm going to put 30% of the width, and then here I'm going to put 70% of the width. And this particles array now has essentially 3 different particles in it. Let's see if this works. No, we are getting some kind of error that P is not defined. Yes, I have here some extra code that I didn't need anymore. Great, I have 3 points now, and they are actually supposed to animate. That means that they are being drawn many, many times per second, but they are not moving in any way. So now I'm going to implement movement into this system. So before we are drawing the scene, I'm going to need a function for updating the scene. Let's make this function be here above it. And I'm going to say that I want to update these particles. So I'm going to loop through all of them, and I'm going to tell each of the particles to move. So this now happens before I'm drawing each particle. So what does the movement actually mean? Well, we could have, we could have movement controlled by properties like gravity, for example, or collisions between objects. Friction also deals with this movement. I'm going to start with a simple movement given by gravity. So I'm going to say G is equal to, let's say, a value of 5, for example. And now I want to move each particles with the value of this gravity. So I'm going to make here a method for move. And basically, I'm going to modify this location y component with this gravity value. So I'm going to say plus equals to g. So yeah, let's see if this works. Okay, something happens. It's actually is moving something, but it's not clearing the canvas before drawing each of these frames. So I need to somehow do this where I am drawing my scene here. I also need to clear the scene before I attempt to redraw all the objects on it. So I'm going to say context clear rect starting at 0, 0, the top left of the screen, and going whatever the canvas width and canvas height are. Refreshing now makes my particles go down, but there is a little bit of a problem here because they are going out of the screen. So maybe I want them to not do that ideally. I'm going to basically, in my update scene, after I have my movement of the particles, I'm going to check to see if my particles are escaping the screen, and if they are, then I'm going to stop them at that location. So let's try to do it this way. So if we are exceeding the canvas height with the y of the particles, then I'm going to say that the y should stay at this canvas height. Yeah, let's see if this works. No. Okay, for some reason this doesn't work. I wonder what the problem is. We need to debug them. So let's see. Hello. We need to check what the particle values are for each of them. And okay. It's still growing. So this y value is not stopping anywhere. Yeah. Well, it should work, but it doesn't. So what gives? So I have the particles here. I'm moving them, so they are changing. Oh, yeah. I have to check the particle's location, not the particle itself. It doesn't have a y value, and for some reason JavaScript doesn't warn me about this. So code just works, it just doesn't do what I want it to do. Great. Yay. Okay, so now you can actually see that these are stopping here on the bottom of the screen. So it's kind of like what I want to see here. Yeah. But I said that I want to implement a more sophisticated game engine. Basically, I want some physics engine here that I could do a little bit more than just apply gravity to some points. I want to have their constraints. I want to have a little bit more more interaction between the elements. So let me try to do that. I think that I'm going to, yeah, I think that I'm going to create a segment class here. So basically I want to have a way to keep these particles at the same distance from each other as they were initialized. So if they were initialized at a certain distance, I want that distance between them not to change as much as possible. So let's try to do that. I'm still going to keep this ugly code here just because we are still debugging at the moment, but I'm gonna get rid of this mess at some point. Let's define these segments here. And say here that I want to create a segment between the first particle and the second particle, so something like that. Then another segment between the second particle and the third particle, and another segment between the first particle and the third particle. It's gonna be kind of like a triangle. So if I'm gonna put this middle particle a little bit higher, let's say I'm gonna have it at 20% of the canvas height, so it's gonna be a little bit higher, kind of like a mountain between these particles, then now I'm gonna impose a triangle using these three segments. So I need to add these into the segments global variable that is there waiting for me. And I need to implement this segment class. So this is actually not going to be very easy. I need to lock in what is the distance between the particles at the initialization, and then keep them at this same distance no matter what happens, or at least try to do that no matter what happens. So let's see what happens. So now these segments are gonna require also a constructor, and it has two particles, right? So I have here two particles. The segment is gonna be formed between these two particles. So let's call this particle A and particle B, for example, and store them as attributes of this object. All right. Now, I said that I need to know what is the distance between these particles at the initialization. So I need to log this distance, this length of the segment, if you will. Okay, length doesn't really let me. I mean, it lets me because JavaScript is like that, but I don't want to see it highlighted like this during my coding. So I'm just gonna call it len, and I need to calculate what is the distance between particle A location and this particle B location. Well, this is going to update Santa and his penguins in the future, but I really want to have a very cool, interesting opponent for the penguins to fight. So this is where this is heading. Be patient. It's gonna take a while. This game is not gonna come overnight. Okay. Okay, the distance, more code. Wow. Distance between 2 points. So let's say this is A and B. This is now Euclidean distance between 2 points, or because we are in 2D space, this is essentially the, well, the hypotenuse in a right angle triangle. So if these are the 2 points and I want to know the distance between them like that, basically I can calculate it if I know this value here, this A, this length is A, and then if I also know this B here, then I can calculate the distance here, which is going to be, for example, mark this C, and C is going to be square root of A squared plus B squared. So this is basically the Pythagorean theorem that gives you the distance between 2 points in 2 dimensions. So let's see. A is going to be basically A dot X, A dot Y minus B dot Y. B is going to be A dot X minus B dot Y. And then C is going to be A times A plus B times B. Right. Easy. And I return this value of C. That's it. Wow. Now I have the distance between these 2 particles at the moment when they were initialized. And let's have also a way to draw this segment. So the same way that the particle has a drawing method here, I'm going to make a drawing method for this for this segment, and using the canvas context, begin path, I'm going to move to particle A's location. Yeah, a very, very long string here. And line to particle B. So I'm gonna move to particle A and I'm gonna have a line to particle B, and I'm gonna apply a stroke. yeah, this context needs to be capitalized here as well. Okay, good. So now we have some segments. They are defined somehow and we are able to draw them, but we are not drawing them. So I'm gonna here iterate through the segments. And draw all of them. This was a lot of code. Let's see if it works. Nope. Hmm. Okay, it fails for one of the particles. So what's, oh, I have 3 here by mistake. This should be 2. Okay, some weird things are happening. I thought that I'm moving the particle in the middle to be higher, but apparently I moved the one on the left. Yeah, I moved this one on the left. I meant to move the one in the middle, so let me change this here. So this is the one in the middle, at the middle of the canvas width. Yeah, so now I have this triangle here. Yeah, well, you have to debug. You can't just uh, ask for help when your code is stuck. So debugging is part of a coder's life, and I don't think anybody really likes it. But if you're good at it, then it doesn't take so much time to fix this. Okay, so I have segments, but they are not doing what I want them to do. I want them to keep this top point there, this top particle, from getting close to the bottom. Because when they are initialized as segments here, I want them to be rigid. I want them to be basically rigid bodies. And this is what we need to do next. We need to enforce this kind of rigidity somehow. And I don't know if I can explain this because I don't have my drawing tablet here. But basically, if I know the distance between the particles when the segment was created, and then if the segment is going to get a little bit shorter, I'm going to force it to increase in size back to how long it was before it deformed. So I'm gonna have to remember, and I already remember here, what is the length of this segment in the beginning. And then anytime it shrinks or it gets larger, I need to stretch it or squish it somehow. And this is gonna be not easy to code, but it's not very difficult if you're familiar with linear algebra. So if you know how vectors operate, then you're gonna really understand what I'm doing here. If not, then I will explain someday, but let me know if you want to learn these things. I think they are quite powerful, and yeah, let's see. So to keep them from getting too close or too far, as I just said, I'm going to have to figure out what is the current length and if it's bigger or if it's longer or shorter than the one in the beginning. Yes, Amir, you're familiar. Okay, great. If I am going to have trouble, then I know who to ask today. So let's see. So in my update method here, I need to calculate the new length. So as this triangle is falling here, the length of these segments is actually shrinking when this point starts to go down and touch this. So that new length, yeah, no, I'm not gonna put it in one line. It's gonna mess everything up. So this current length, I need to get it somehow from the current location of these particles. So pretty much I'm gonna do this, the same thing as previously, but the particles have moved since this segment was first initialized. So this current length is not necessarily going to be equal to the length that I have here. Okay, now this is basically a value that we need. So this is the one in the beginning, and this is the current one. And I need to know if this is bigger or smaller. So I'm going to calculate a difference between the current length and the one that we have stored at the moment of creation here. Now, this difference I need to use to stretch it or to squish it, the segment, to be in that same value as in the beginning. So this is much easier to do if, for example, I implement some helper functions. Yeah, first, really good helper function would be a normalization function. So basically, I want the vector that is going to affect this direction in which I'm going to stretch the segment or squish the segment to be normalized to have a magnitude of 1, and then I can multiply it by this difference. So I really need to have some kind of methods here that work with vectors. Let's try to create these. So add two vectors. Let's call this v1 and v2. Because they are 2D vectors, I'm going to use the x and y attributes there, and I'm going to say return v1 plus v2, and yeah, something like that. So this is helper function so that I don't have to write 2 lines of code every time I need to add 2 vectors. Then I could also use a helper function for subtracting v1 and v2. So it's pretty much the same as addition, but yeah, just that. Then I think we also need, what do we need? Yeah, we need the normalization. So normalization is for one vector, and I basically need to return a vector where the values are divided by the vector's magnitude. So something like this, but I need to know the magnitude. And the magnitude is just how long the vector is. So actually, all vectors are centered at the origin, and then when you want to calculate the magnitude, it's basically the same thing as the Pythagorean theorem here, but one of the points is always 0. So actually, your differences here, A and B, A is going to be exactly the Y value here, and B is going to be the X value. So if I go here, I can calculate it as square root of the X value squared plus the Y value squared. It's essentially the same thing as there. And then I'm getting here the normalized form. So let's see if I can use now these to my advantage here. Basically, to get now the normalized vector of wherever the particle A and particle B is, yeah. Okay, wait, I'm a little confused here. So this is a length value. This is a magnitude of the difference of these two vectors, right? So I could actually, let's get the difference. So this diff here is a scalar, value, but I want to get the difference vector of these. So it's gonna be, let's call it dv. It's gonna be subtract this particle A location and this particle B location. So subtracting two vectors gives you the vector that is connecting the tips, basically. Then this one is what I need to normalize. So let's call it norm dv. I'm going to normalize the dv. And I have now to scale this with this difference divided by 2. So I need to scale it in one direction and then in the other direction with this difference. So let's see how this goes. Basically, particle A location is going to be whatever the particle A location was. So I'm going to write here add the same value of this vector, but then I need to scale this normalized vector by half the difference, the scalar value there. So scale normalized vector minus difference divided by 2, or yeah. Okay, quite tough code here. I hope I'm not making any mistake. So if my segment is getting smaller than it should be, this point here needs to go back up half the difference. And this one needs to go other direction, half the difference. So I really don't know if I'm messing this up here, but I hope it's gonna work like magic. Yeah, okay, let's see. So I'm missing the scale function, boy. So this scale needs a vector. Let's call it v1 and then a scalar value, so something like this, and it just multiplies each of these values by that scalar. So easy. And here we have this difference. We have the normalized vector. We are moving particle A, we are moving particle B. If I didn't mess up, then this should work, but it doesn't work. It doesn't work at all. So what is happening here? Let's see. Let's try to debug. This doesn't exist. What is? Oh. Still nothing and no errors. Okay. I'm gonna debug a little bit what this difference is. What? Oh, I'm not calling the update method anywhere. Oops. So in my update scene here, I need to at some point go through all the segments and tell them to update. Yeah, so this method that I worked on so long wasn't called anywhere. So now we see if I have errors or not. Yeah. Subtract is not defined. Did I call it? Something else? Should be subtract, so add subtract. Wow, okay. This is something interesting. I think I messed up. Did I maybe add this half value in the opposite direction? No, I think it was correct. I broke the universe. I'm sorry, I broke the universe. Yeah, well, JavaScript is actually quite permissive with this semicolon. Actually, I think you shouldn't even use them. But I'm so used to other programming languages that let's just say that I will always put it as a reflex. So I don't think this is the problem, but something is definitely a problem here. And so we have this difference between particle A and particle B. Then I also have a different scalar value between essentially the magnitude here and the length that was stored. So this should be okay. Then I'm normalizing this current vector value there. So I'm getting a small vector that has a magnitude of 1. And then this should be good. So then I'm scaling this with half the difference that we just calculated, right? And adding this to the particle A location. Yeah, maybe I can show you my skills. Taking a little break. It's it's becoming time for a break. So yeah, let's see. I'm not as good as you. I remember seeing your YouTube video about how great you finished this game. Uh, I'm not the worst, but you would expect more from one of the guys that helped make it. So, yeah. So did you use an auto clicker when you played on YouTube or what?
Ville was talking about food.
Hmm. Tough game, tough game. Okay, I guess I did it. Yeah, back to my broken physics. Hmm. Yeah, you did. Under 15 seconds. I can't believe it. Aha. Okay, so if you're good at Minecraft, then you're probably gonna be good at whatever this is gonna be, right? Well, that's cool. Something doesn't work here. Okay, back to thinking seriously. Hmm. Yeah, well, I don't think that these tentacle monsters might necessarily need to obey the laws of physics. So maybe we make something with this thing, whatever this is. What is this and what is happening here? This is very weird. Hmm. Yeah, so maybe I actually try to open something to draw. Just a second. I have a new computer and I don't have uh, tools on it yet. So so say hello to Paint. Yeah, the X values. Yeah, let me make a recap here and then we look at the X values. Thanks. So yeah, the recap, what I'm trying to achieve. I have a segment. So in the beginning, we have 2 points. We have particle A and then particle B here. And we are learning what is this length value. So this is what we are storing in um, this dot length there. Now, if something happens to this segment, and for example, the points become closer to each other, like this, I want to calculate the difference between these two. So my difference is going to basically be something like basically something like D1 and D2 here. So the difference is going to be D1 plus D2. So basically the difference in whatever this length is and whatever this length is, I will calculate it in this value. And then what I want to do is relocate these points according to this directional vector so that it takes half the difference, so half of this in one side and then half of this in the other side. So basically I want to either stretch this new vector back to its original length, or if for some reason this is bigger, I want to squish it back to its original length. So I want to move these points half the difference in one direction and half the difference in other direction, basically. Yeah. Yeah, okay. So maybe I'm doing that. Let's see. Back to the code now. Distance from the center. No. No. So, okay, this difference here should be the distance between particle A and particle B. And this length here is the distance also from particle A and particle B, but before they started to move at the moment of initialization. So this should be basically correct, I think. Translate both points by A, then scale not by difference, but by division. I'm scaling them. I'm scaling them before yeah, okay. So Amir says, translate both points by A, then scale not by the difference, but by division. Then translate by A. I think you're probably trying to solve it another way. It should be equivalent, I think. So I'm adding to particle A the difference by minus A. What is A in your notation? Let me have a quick look at my methods here. Maybe I did some mistake. So I have the addition of the vectors, the subtraction of the vectors. These look okay. Normalize. Scaling. So I have the scaling here, multiplying by scalar value. I think this should be correct, but then normalizing, so normalizing gets here magnitude. Hmm. I don't think that there is any mistake here. So yeah, I think these are fine. Okay, particle A. So translate both points by A and scale not the difference but by the division. Do you mean from the center point? Yeah, okay, let's set the breakpoint. Thanks. I didn't. Let's do that. Yeah, how do I make this bigger? Okay, let's see. So current length, okay, let's restart this page. And break on the first time this happens. So I should have now this length equals to 181. And I think that the current length should also be equal to 181. It's not. Hmm. Okay. Why? Let's go back to the main code. In the update class. So here I have the particles move according to gravity. I also have a check if the particles are going outside the screen. And then I have my segments update. So if all the particles are moving down the same way, I expect them to be still at the same relative distance from each other, right? Okay, thanks. So F9. Yeah, but it makes me go into this subtract. I think F10 probably is more useful here. Okay, something weird happens. So I don't understand why this current length is 78 now and compared to 72 there. They should really be the same values in the beginning. So if I disable here the segment update and my breakpoint, you can see that in the beginning when the things are falling, there is nothing keeping them, nothing changing their relative distances to each other. So this current length here should not be different than this length, at least for several frames, for several good frames. Yeah, I don't think I am. Am I? Let's reactivate this. So this length here is set before the breakpoint. It's set once, and it should always be the same value here. But this one is the one that is changing. So let me try to advance with F8 here, go to a different segment. So now I have this another segment, 72 length, and then this is 78. Now I advance again. This is 181 again, so probably the other segment that is symmetrical, and then this 180 here. Huh. Okay, I may know what is happening here. I think that one segment is getting fixed, and then the other segment breaks apart, and then somehow one iterates after the other. Wow, it's normal, but somehow I'm not prepared for solving this now. So could it be that one segment gets fixed and then another one is broken? Let's try to remove one of the segments from here and see what happens. Okay. And let's try to remove also another segment. So, okay, no, it's not that. It's definitely something is weird, because now there is a single segment there and something strange is happening. I don't really understand what is happening here. This code is not affecting. Now nothing happens, even though the segments are updating. So I think that if I put a breakpoint here, my current length is exactly equal to this other one. And nothing actually happens as expected. But then when they move, something strange happens, and I don't get it. So let's try to force this code here of moving the particles while debugging here. So now I'm moving it for one step, and let's play this. Okay, so now we're getting again these weird values, even though all of these particles should have moved the same amount. So what is really happening here? Wow. Okay, let's try again. The location of particle A is this value. Does anybody know how I could copy these values? It seems like, okay, it works. So this is PA in the beginning, and particle B. And now let's move them once like this. Go back to the code particle A again, and now particle A has moved on the x-axis. What? Yeah, I can go. I can go to the moving part. Okay, this is really weird. So in the moving part, I just update the y location with g. Okay, let's try to redesign this a little bit. So well, since we're using vectors now, maybe I'm gonna say here 0 and 5 on the y-axis. And let's say now that here in the moving of the particle, I'm going to consider also the past location of the particle, because now this moving constantly by g is not how physics works. It actually needs to accelerate by g. So maybe if I redesign this to make it more proper, the bug goes away. Let's see. So the velocity of this object is going to be whatever this location is minus old location. So let's store here also the old location of the object, and then the new location is going to be adding to this location this velocity value. And because I want to use this g as well, I'm going to say new location is adding to this new location the g global variable, which is now a vector. So this is now updating a new location, and I have to keep track of the old location is equal to this location, and this location is going to be this new location value. Let's see, does this do anything differently? Nope. Why is everything broken now? Oh, I'm getting some weird values here. Oh, yeah, let's go. Oh my God. Wow. Thank you, Amir. Yes. I think Mari was right earlier that it's something that you just don't see until it's too late. I basically broke the code going to the particle, and now I tried to be too smart here. Yeah, let me try to fix what I was trying to do here. So first of all, I want to remove that, calculate velocity based on the old location and the new location, add it to the current location, then add g on top of that. So now we're working with vectors here, and then make the old location the current one and update the current one. So this in theory should work. Okay, something works. I need to make the gravity lower. Okay, Amir, I think you solved my problem. Let me reactivate the particle constraints here. Gravity even lower. Let's make it one even smaller. Okay, something happens. Let's reactivate also the segments here. Yes! Okay, this was very, very tedious, and when bugs like this happen, it's just... Yeah, thanks to all of you, because this debugging there, we actually saw that the X value was changing, and it was changing without any reason. All the particles were just going down with the gravity, and the X shouldn't have changed. There was no reason for that, but because we were calculating the distances with the wrong distance function here, like there was the y there, it somehow messed everything up, and the x's were changing as well. And then we were getting that weird, very weird behavior. So thanks to all of you, like a lot. had some not so much fun figuring this out. Took like maybe half an hour at least, but now we have something that looks like, well, looks like something we can use. I still have energy, so I will continue. I remind that we are supposed to have a weird tentacle monster appearing, and at the moment we just have this triangle monster, so boring. Yeah, sure, I will post it on something, either on GitHub, or I post quite much on CodePen more recently. I will definitely link it in the comments. Yeah, great. Okay, let's go on. So I want to do some kind of more interesting things here. Let's make some of these points static. Maybe we make this point here static so that it won't be moved by any kind of external forces, and see how our physics behaves if we do something like this. So I'm going to go to the particle class and have a secondary attribute. So by static, it just means it will never move. And I think we can say here that this is by default equal to false. So by default, the particles move. But if it is static, they will not move. So here in the move, basically, if this is static, I could do that. I will not execute this code on the bottom below it. But then also the movement here inside the segments, see some of the particles are being affected if the segments are going to adjust. So I don't want to affect the location of particles that are static. For example, here if this particle A is static. If it is not static, then I want to update its location like this. And the same thing should go for particle B here as well. So only if particle B is not static, then update it, constrain it with whatever the other segments are. Now code still works as before because none of the particles that we are creating here is static, but let's make this rightmost one, be static. Okay, this is not the correct place. This is the location here, and this is the isStatic attribute, which I'm forcing to true. So now what happens is basically one of the points is never going to move, but the others are going to move. They should go down. They should go according to gravity, but because we are constraining the segment lengths, even if the points want to go down, the segment length would increase. So then the segment length is going to make it constrain and move it now horizontally on the x-axis. And what you're getting is essentially this kind of pendulum movement here, because the particles are first taken to the right, and then as they are going to the right, they start to increase in that direction. So then the segment constraints are going to pull it back towards the left. So it's a bit hard to digest all of this, and I'm a bit sad that I don't have my tablet here to draw a little bit more of what is happening. But essentially we have something that looks a little bit more useful. And let's try to create something more interesting with more points and more particles and generate them using code, not using these kind of external, these kind of hard-coded values here. So let's start creating a class for our monster and say that we want to generate our monster at a given location. So let's store this location in the local attribute here, this location, similar what we did to the particles previously. But now let's generate some kind of structure for this monster. So what I'm going to do is say here that this monster is going to be made from particles and segments. And I'm going to say this particles equals an empty array, and this segments equals an empty array. And now I'm going to populate these relative to our given location here. So I'm going to say, maybe let's just at the beginning try to generate a row of particles relative to this location. So for let I is equal to location dot x minus maybe step is equal to 10 pixels, step times, let's say we want to generate 5 on the left and 5 on the right. So something like this. Yeah. Okay, now for these different values, I'm going to get a new location, and I'm going to say this particles push and new particle at the new location. So our x value here is going to be this location dot x minus y I multiplied by this step value. And our y value is just going to be this location dot y. So now I'm generating these local particles, part of this monster class. And after this is done, I'm going to just go through these particles and generate also segments. So this segments push new segment of particles of I minus 1 and particles of I. So between every consecutive pair of particles, I'm going to have a segment, and I can start here at 1. So this is now trying to generate segments without copy pasting so much code here. So I'm going to remove all of the code that we had previously, and I'm going to just say monster is equal to new monster at the center of the canvas. So the x is going to be at the center x, and the y is going to be at the center y. Yeah, let's have this as a global variable now. And when we are updating the scene, I actually just want the monster to update. So all of these things will not exist anymore. We get rid of the global variables, and our monster class is going to have here update method. And what it's going to do is it's going to move its particles and its segments only. This way we basically encapsulate where these using these attribute values there. So does this restructuring work? No, we have some bugs here. Anybody sees the issue here? So missing right parenthesis, but it's here. Oh, I have semicolon here. Oops. Yeah. Okay, still some problem. I'm missing this. And again, semicolon here. Let me align these a little better. Okay. I'm missing a draw for our monster. So let's make this draw method here. And in our draw scene, I'm actually going to say monster draw. And here I need to replace these with the local values. So I just don't want to deal with global variables. Maybe we have multiple monsters, they will share the same global variables, and then it's a mess. So I want all these to be part of the same objects there. Okay, something is there. Let me increase this step size a little bit. Okay, I'm gonna move the monster, boring monster, a little bit to the top, maybe like this. And now I'm going to make this middle particle be static. So if I is equal to 0, something like this, and send it here in the particle constructor. And now what we are getting is this weird kind of double pendulum thing. It's not a double pendulum, it's actually a multi-pendulum centered in this middle particle there. And this is kind of where I was wanting to go with this idea, because they kind of look a little bit like tentacles or some kind of limbs that have many joints. Now you could control these to have a smaller step size. So maybe here we could have a smaller gap between the points, and we could have more points, something like this. Kind of interesting behavior. Some of these segments are longer than others, and I think that there is some mistake in the code, in the logic. I need to look at this now. And it's also a little bit, you can see them, they are a little bit elastic. I think this is because of what I mentioned earlier. So one segment increases in length, then it's adjusted, but then it breaks another segment. Then the upcoming segment, it is adjusted, and then it breaks the previous segment. So somehow the problem is that this should be iterated either multiple times, or a smarter way of doing this. But if you do it too smart, if you try to consider all of them at once, then it's going to be very hard on the processor. It's complicated problem to fix. So usually what people are doing is that you iterate the segment constraining part multiple times. So here in this update step, I'm moving the particles, I'm constraining them to the canvas size, and then I'm also updating these segments to be the same values. But because after you update some segments, future ones are breaking the previous ones, you may want to repeat this step a few times. So let's see what happens. It should form these, it should make these segments be a little bit more rigid here. So if I don't do this, let's call this value here rigidity. Right. If I put a low value for this rigidity, let's say 3 or so, then note now that these are touching my mouse on the right. But if I refresh, they are now going a bit lower because some segments are stretching and then the next ones are stretching and the next ones are stretching, but they are affecting again the previous ones. So if you repeat this multiple times according to this rigidity value, you actually keep the size of the segments closer to how they were initially defined. Now, the more you repeat this, the better, if you want to have really rigid segments there. But the more you repeat, the more computationally expensive it's going to be. So it's somehow a balance between these two things. Are you guys following something, or am I just not explaining things well enough? Because I think that I should have prepared with some kind of material for this. I actually taught this some years ago. Here, yeah, I had a lecture about this. So in this lecture, I actually have a bit more material there, and we are making some kind of more complicated shapes here. Maybe I'm gonna link this also if somebody wants it. Let me try to get this link somehow. In the chat. Yeah, okay. I only if you're really interested in this, you can check out that. But otherwise, let's just continue this and figure out where this is going. Okay, so now this is creating basically a line in the beginning. And if I don't update my monster, you can see this initial line here in the beginning. The center point, I made it static. So that means that only these two tentacles move a little bit. So yeah, but how about making more tentacles? So this kind of octopus creature is named octopus for a reason. It has 8 of these. And I'm gonna try to generate 8 of these lines of particles and segments somehow. So let me try to do that and change this code a little bit. I'm not very happy with it at the moment. I think that what I want to do, let me try to share this paint screen again. Yes, of course, we need more. More of them. So let's consider this as the center point. So this is now the location of the monster. And I want to generate these tentacles as something like some particles going like this, with segments in between, some particles going like this, some going like this, some going like this, but 8 of them. So basically twice as many as what you see here. And I think that I'm gonna start generating this by considering these kind of circles. So circles centered at this, but increasing the radius. And then as I'm increasing this radius, I'm going to generate points along every new circle. And I'm gonna repeat this a number of times. Let's say how long we want this tentacle to be, basically. So let's say a number of segments for this. I'm gonna put it to be 10, for example, and I want 8 of these legs, basically. Okay, really hard to draw with the mouse, but hope this is kind of understanding what I'm aiming at. Let's go back to the code and try to do this. So I'm just going to go move this code below, and probably I won't need it anymore after I do what I want to do now. But let's keep it here for copy, pasting, whatever. So number of segments, I said 10, and legs equal to 8. Okay, so because I want to generate essentially 8 times 10 particles, I'm gonna need 2 for loops here. Right? And I want, first of all, to have a particle that is static, and it's going to be the root of the monster. And this is going to be exactly at the location. So let's copy this code before generating these legs. And I'm going to say here pretty much a particle at this location. So nothing too fancy, and make it static. Now these segments and legs here are going to add more particles relative to this location. So let's see where this is going to go. I want the radius of the circle to depend on which segment we are. So the radius is going to be equal to I multiplied by let's have here also a value for the step. So I'm going to keep this, what is the distance between particles, basically. Okay, and I multiply this by the step. Now that I know the radius where I'm going to generate this, I need to know which leg. So this is going to be angle value, essentially. So I have 8 different legs, and I need to somehow divide the 360 degrees or 2 pi radians into 8. Let's begin like that. So it's going to look more like a spider web in the beginning, going all different directions, but then I want to limit the angle to just below the head of this monster. So I'm going to say here, to figure out the location of each individual particle, like location is equal to, I'm going to take this radius into consideration and this main location of the head into consideration. So I'm going to say the x is going to be this location x plus, wow, a Sonic game. Yeah, well, trigonometry is not that difficult. Nothing is really difficult if you practice it. Like, if there is something that you practice enough, you're gonna start to be good at it and know how to deal with the things. So how about this Sonic game? Do you have a link for it? I would be curious to see what you're working on. Yeah, so I think that we need to do something like the cosine of the angle here. So I need the angle. Angle is equal to 2 pi, so the number of radians of a complete circle, but j is going to take a fraction of that. So let's say j divided by legs. So this is now giving me a value between 0 and 1, multiplied by the full circle radius. Now here we are getting the x value relative to the main head location, then the cosine of this angle multiplied by the radius. That's it, I think. And I'm gonna do the same thing for the y, but this needs to have sine. So trigonometry, you should know that you have unit circle and it's divided by the cosine and then the sine. So this horizontal part and the vertical part. Yeah, squaring these and adding them up is equal to 1, but now we're scaling it by the radius. So a lot of math going on here, and I'm not explaining it very well, but it's interesting to see just what can come up from it. So I have here now the location, the angle, the radius. So let's generate a new particle at this location. I don't want it to be static, and I just want it to be at the location that I just calculated now. Great. What is rage? What is rage? I don't know what rage is. So you have a browser-based Sonic game. Is it also using the canvas? Yeah, okay, let's see. I'm gonna now comment out this code here and see what we have at the moment. We have an error. Okay. This needs to be true, so a static particle is created there first. Okay, we get this now. Really Amateur Games Expo. Wow. Well, this is not going to be a game today, but I'm hoping that I'm going to get some kind of creature by the end of whatever I'm doing here. So it's part of a game whenever the final game is going to come out. So I don't think I'm going to submit this anywhere anytime soon. Oh, okay. So is it like sliding divs or some other HTML tags around? So it's not using the canvas, I guess. Okay, but now here, if I modify the angle to be less than 360 degrees, like for example that, I'm gonna get these tentacle things going just in part of this monster. So I could do, for example, half pi here, and now I'm getting this kind of thing. Yeah, okay, interesting. So game using divs. I haven't seen that yet, but I think why not experiment with these kind of things? I think it's fun. Okay, but maybe I want to also offset this angle by some value so that these are not coming all on one side like this. So let's try to offset this by maybe pi. Nope. Yeah, I'm really lazy. I don't want to calculate exactly how much I should do this. If somebody wants to do some math magic for me, then great, but I'm just eyeballing it for now. Okay, so particles are now like this, but maybe I want the segments to also generate at this point. So when I'm creating a new particle here, I want to attach it to the previous row. So the previous particle there. Yeah. Actually, I want my segments to start at 1 because the first, otherwise there are many particles overlapping here on the main part of this monster there. And here, when I'm generating these, I'm going to say if I is equal to 1, so this is going to be the first, these first level particles here. I'm going to attach all of them to the first ever particle in this array. So I'm going to say this segments push new segment of this particles. Okay. A little bit refactoring here so that I don't have to access this from the array. So new segment between this P we just created and the first particle in the array. So this is going to be now the root of the monster. Otherwise, if we are not on level 1, so if we are some of these other levels, I want to attach these particles to the previous level here. So I'm going to say this segments push between P and the particle that is, I believe, legs values before it. So if I'm here and if I have index, let's say index I, if I do I minus legs, I'm going to get, I think, the index of this particle. Let's see if this will work. So something like this. Hope this works. No. I think it needs to be minus legs -1. Yeah. But I'm kind of curious to see what happens if I don't do this minus legs -1. Let's try to reactivate the code that updates our monster. Oops. That updates our monster here. Here. Interesting. So it's not what I want, but it's something that is kind of interesting. What is happening here? Sometimes these mistakes are fun to try out and see what is happening. So back here, I'm missing this -1 when I'm doing the indexing, and now I get this kind of realistic movement if you think that these are just somehow connected to a single point and gravity is the only thing that is affecting them. All right. Okay. But I actually want to be able to control some of these arms of this creature. So yeah. Yeah, well, I think that you can always do mistakes. You will always do mistakes if you're trying to do these kind of things on the fly, and if you're trying to do these while doing something else like talking and explaining. So if you prepare some good lecture material and then you follow that lecture, then it's okay. Probably mistakes won't happen, but I think it's fun to experiment sometimes and not worry about all these small details. Also here, this code is not fantastic. It has a lot of these nested statements. I think this could be made much better. But I'm just playing around to see if I want to create this octopus in this way. Maybe I don't want to have this way of controlling the character. Maybe I want it to be implemented in a completely different way. So I'm just prototyping and trying to see what works and what doesn't. Yeah, sometimes you just do something like budge things together, and then if you like it, then of course should refactor the code and have it cleaned up. But if you don't like it where it's going, then just delete it and try something else. So you can't really predict what it's gonna be like unless you try. Sometimes it's really hard. Well, yeah. Maybe I can talk about how to make this code better someday, but at the moment, I just want to see where this is going. So I think I'm still gonna give this thing a few minutes today, maybe half an hour, and see if I can get some kind of interesting result out of it. what happens if we integrate some kind of mouse movement here? Let me try to control this static point here on the top using my mouse. Maybe I like the behavior of this object then. So I'm gonna do this by adding an event listener for the mouse down, I think. And I need also mouse move. And I need also, wow, I need also mouse up. Okay. So these functions are something that I need to implement now. I'm going to need to search what is the nearest particle to where I pressed my mouse. So this event has a X and Y value similar to the location. So I'm going to have to get nearest particle from the event location. So I basically treat this as a location, even though it has many more other attributes there next to it. But it does have a X and Y, I think. Let's see. So I'm passing now this, and to get the nearest particle, I have to go through all particles of my monster. So now I would have preferred to have that global variable there, but let's see. So going through all the monster particles and calculating the distance to this location. So yeah, something like that. And I need to get the particle with the minimum distance. So let's have minimum distance initialized with a really big value. And then here, if our distance is smaller than this, whatever the min distance is, we update our min distance and our nearest particle becomes that. Right? And here, I want to return the nearest particle, a static property in the monster class. So what should I use the static property for? Something like this. Okay, now once I have it, I'm going to say particle location.x is equal to event.x, and particle location.y is equal to event.y. That's it. And I have the mouse down here, but I need to do the same on mouse move. If the mouse has been down. Okay. yeah, I'm just gonna make this work somehow. So selected particle is that unmouse move if selected particle is not null, then its location is going to be updated, and this selected particle null in the beginning, and unmouse up, yeah, unmouse up I want to make it be null again. So I'm only going to update the selected particle when the mouse is down, and then it's just going to disappear. Let's see if this code works. Okay, so now when I'm clicking this main part of the body, I'm actually moving this creature around, and the limbs are actually moving in a way that you kind of expect they would move if you have something like this in real life. I could also click some of the points here. It's not really what I expect. So if I'm not moving the mouse, even though I'm holding the button down, physics starts to kick in. So a little bit more, I want to somehow hold it here and maybe figure out if I can make the monster move in a way that I like, but test how the movement would look like by just dragging it with the mouse. So before I program some kind of logic for how the monster would move his hands to get the player, I would like to see how it looks like by just controlling it with the mouse. Yeah. Yeah, well, Amir, your fault for leaving. I don't think that it's anything too spectacular here. It's just basic particle system and this kind of rigid connections here. So there is no collision detection really. It's just me with my mouse selecting the nearest particle here and moving these things around. But I want to be able to hold this, and now it's fidgeting like crazy. So I think the problem is that I should make these particles static at the moment when I'm holding any particle with the mouse. But then when I release, I want it to remember that this main body part here should still stay static. So if I, for example, do something like this, and then before I set it to null here, I set this back to false, I think that, yeah, now I'm not getting this fidgety motion anymore. It's actually something that I would like to have. It looks good. So if the creature would somehow move like this by itself, I would find that really interesting. Maybe we can work with this after all. I kind of lost hope at some point. So, but yeah. But the problem is now if I release this, when I release this, something weird happens. But also, if I grab the middle point here and I now release this, the thing falls down. So I'm losing the isStatic attribute of the selected particle by putting it to false. So yeah, maybe I do something like this. Not very clean, but I guess it's gonna work. So when I set it here to be static, before I do that, I actually record the previous state, if it was static or not. And then on mouse up, I'm gonna put it back to whatever it was previously. So I hope this makes sense. So now after I release, it stays there. It's what I expect. But there is still this weird, when I release now, it jumps up. So the problem is that I have the location of the particle and I also have the old location of the particle. And that old location is affecting here somehow. I think the problem is on mouse up, I should also set the particle old location equal to the selected particle location. And I think that these are shortened like this. Yeah. So this is probably going to give me exactly the effect that I'm looking for here. Let's see. So I release now. Yeah, good. So kind of crazy thing here moving. Let's try to play a little bit with the gravity. I think it's somehow way too strong. If this is gonna be underwater, then this is actually something, yeah, this is something that looks much nicer if you would think that this creature is underwater, then the density of the water makes the limbs move slower than they would in the above ground. And now if I'm moving also this, yeah, something. I think we can work with this. Okay. Yeah, I think that we can work with this, but probably I'm not going to continue too much longer today, maybe just 10-15 minutes max. I'm not going to implement the movement so that this monster guy is going to move by itself, but I am going to try to make it look a little bit more interesting. Now these limbs are attaching to a single point, and maybe I'm gonna make this head part there. And instead of making them attached to a single point, maybe I'm going to make them separate a little bit here. Let's see if I can do something about this. So basically what I want to do is on this level here, I want to create some solid segments between these so that these points don't come close to each other. So at the moment, there is no segment here. This is not a segment. This was just my drawing of a circle previously. The only segments are these connections here. But if I'm gonna add some segments here, then these points are going to not be allowed to go close to each other and overlap. I think that this is going to be an interesting kind of structure for our creature there. Let's see. So back to our monster, where we are generating these legs. So I remind that we are using now here this kind of unit circle properties, a radius value, and then this angle, somehow a section of the circle there. So here, this is our level 1. So this level 1 basically means here. And all of these particles are attaching now to this one point there. I want not just to attach them to that main point, to these particles of 0, but also, yeah, also to the previous particle, to the last particle that was generated before this P. So if particles length is greater than or equal to 2, so I do have one previous to this P value, I'm going to, yeah, I think this is gonna work. I'm going to also attach P to the particle of this particle's length minus 2. So I need to do this check here. Oops, I need to do this check here because otherwise I'm going to have here an error popping up when I want to connect this particle to a previous one. Or actually, it will connect to this. Okay, damn, this is a mistake here. I think I need to say, so I do have one particle already existing. So here, if the particle length is more than 3, actually. Yeah, let's see what we get. Okay, I think I was lucky. So it is somehow something I expected to get. So let me make this monster a little bit bigger by playing with his properties here, like the segments, the step between the particles. Let's make this 50. So now it's a little bit more visible what is happening here. Let me make also the size of the particle to be smaller, like 2 pixels, the radius of the circle. So now you can see here these structural links that I added in the first level of these things. And now when I'm moving this creature around, I'm getting the yeah, I'm not having them come closer to each other. So this can be seen as something like the base of the head, basically. And I could just draw something here, like maybe I draw this first particle to look like some kind of weird circular shape. I could just make it as a one bigger circle at the moment. Let's try that. So I will have to define some kind of skins for these objects, and maybe I will use a little bit of curves here. Let's see. but at the moment I just want to see if I'm happy with this movement and if this can become a character that is more interesting than just using some kind of sprites. So I think that I like this because the movement of the limbs is chaotic. It's something that you cannot really predict. This is kind of like the definition of having multiple pendulums like this. These multi-pendulums tend to behave in an unpredictable way if the initial conditions are just slightly different. So I kind of like the idea of having a character that behaves uniquely, so to speak. Okay. Yeah. So I'm gonna just skin this quickly to make the first particle look a little bit bigger, maybe much bigger. And I don't care much about the code quality now. We will refactor this later. I think this is promising. Yeah. I'm gonna make this character have now the step size smaller again, maybe 20. Here was good value, or maybe 30 is even better. Okay, I'm gonna move it a little bit lower. So to start at maybe 30% or 40%. Yeah, I will add the code somewhere. I think that I will put a link to CodePen most likely at the end of this thing. So after a few minutes, I will stop. I'm tired. And I will put this code somewhere, but it's messy. So you can play around with it, but I will refactor this at some point. And I think that this monster is going to be great, but it's not there yet. Maybe next time. So now it's still doing some weird things here, and it's not moving. So maybe next time I'm going to have the monster chase my mouse button. So that if my mouse is somewhere, it's gonna move its tentacles to try to grab the mouse by itself. Let's see. I'm kind of curious to see how that will work. But yeah, just as a quick fix here for the design to get a better idea of how this looks like, I think that I'm gonna go in the particle class and I'm just gonna say that if this is static, when I'm drawing this, yeah, so if this is static, so the only static point now, no, it's not enough because the particles become static when I click on them. Okay, let's give it another attribute here for big, for head actually. So yeah. Okay. So here it is head. I'm gonna make the radius, for example, 10 times bigger. Now, replacing this with this new radius that sometimes it's small, sometimes it's big. I should get something like that. And well, I could do some more strange things here, like scale the context. Maybe I keep it the same horizontally, but I scale it just vertically a little bit. I could do this, and then I also need to remember to restore it at the end. So I only scale it if this is the head. And that means that I'm now getting this oval shape, but I'm scaling it relative to this 0, 0. So yeah, I need to do some weird things like translating it first to this location X. So I want to scale it relative to the center point. So I'm translating it there. And now because I translated the canvas, I can put here 0, 0 because I'm at this new location. Okay, so now my head looks a little bit like an oval shape. Maybe it can be a little bigger here. Yeah, so not a big change, and I would actually prefer this to rotate. Yeah, I would like it if the head would rotate. That would be nice. So now these other things are rotating here underneath the head. Let's see. I make the head transparent a little bit so that I see behind it. And I would like to have the head actually rotating to the middle segment that is connected from the center of the head here to some of these particles, to the one in the middle there. So yeah, basically I would need to know what the angle is there. But this is something that the monster knows, not the particle itself. And now the code here is messy. So this is not how you skin something. This is just me trying to figure out if this is the direction where I want to go with this. And I think it is. Yeah, let's see next time. So I will put the code as it is here, the code pen at the end of this. And I think that's it for today. What do you guys think? Any kind of questions or ideas where I should go with this? I basically want a character that somehow moves naturally and looks more interesting than some kind of fixed sprite animation, and maybe is actually hard to defeat or has a little bit of logic assigned to it. And of course, I'm going to skin this to look nicer. Now it's still in this kind of debug mode where I have just these circle points there and lines for the segments in between. But I think that I'm gonna skin them so that the tips are pointy and then they become more thick as we are getting closer to the center. Actually, I could quickly probably maybe here I can store width. Again, this is not a good idea to style it like this, but I can do it quickly and I can figure out if I like what I see or not. And here I'm going to say line width equal to this width before drawing the segment, and I'm going to default it to 1, which was previously, so now it looks same as before. But when I'm generating the new segments here, I'm going to set the width equal to I. Okay, this is probably gonna be in reverse of what I want to do, but let's just see here. So so I'm sending now the width with these segments. Yeah, it's basically in reverse, but okay, really. So how long have you been in tourism? So this I'm actually gonna do opposite way. So I have the number of segments here. So the width is gonna be number of segments minus 1 plus 1 minus I. So now the tips of this are going to become more pointy. And of course, if I want to, well, I don't know. I actually kind of like those dots there. It looks a little bit like like bones. Like if you have a skeleton and you see these the hand, and then you see the joints where these whatever they're called, it kind of looks a little bit like fingers here, and it's a bit creepy. I kind of like where this is going. It's a little freaky, but if it's some kind of enemy here, then yeah. Oh, okay. So why did you change to coding? Is it something that you kind of heard it's a good idea, or it's something that you're interested in? Or I actually like quite a lot this kind of creative aspect of coding because, well, I like things like drawing or painting or sculpting or things like that. And when you're coding, you can do something like this that does a little bit more than that. It allows you to do user interaction, and you see this animation happening at the same time. And you also play with math concepts that you maybe have learned over the years. So, yeah. Oh, okay, great. Yeah. So, second year of bachelor studies. So is it also in bachelor's, or is it master level second year? Hmm. Aha. Yeah. Uh, I don't know if this will happen to you, but it happened to me. Um, Games stopped being so interesting after you learned a little bit about how games work. I don't know if this makes any sense, but basically, um, I was in high school and I was really into games. I was playing a lot of games, playing with friends or playing by myself, like RPG games or racing games or sports or whatever, a lot of things, racing games, whatever. And then at some point I was getting into how games are made, and then at some point I just got really into making games or making this kind of application. And then anytime I would play a game, I would think, oh, how is this made? How is that made? And if the game had some kind of story to it or some kind of, you need to immerse yourself in it, I was immediately pulled out from it. So this still happens to this day. And I can't really enjoy games so much because I'm always kind of thinking, ah, so they did it like that. Maybe I'm gonna use it in some of my projects. And then it's like, what was this story about? And I just get taken out of the mood. So I hope this doesn't happen to you, but a small warning that it may. Yeah. Hmm. All right. So I think that's it for today. And next time, I think that we are going to continue with this thing and try to make it do something smart, like uh, maybe interact with my mouse in the beginning, and then basically we can include this monster in some other kind of game. Yeah, let's see if the code actually supports multiple monsters. Just quickly here. Is it hard to try this actually? Let's make this monsters push new monster, and let's have it push another new monster. um, so this monster is now monsters. And get nearest particle. Whew. Yeah, I think this is hopefully going to work. I'm also doing this because I'm interested to see how um, how multiple of these creatures would look like in the screen and how would they interact with each other. So just getting ideas basically. It's the point of all this now. Okay, some error here. What? Oh, should be an empty array. Yeah, seems like code actually handles them. So my code is actually not that bad in the structure, from the structure point of view. It does let me do uh, this kind of stuff quite quite easily, like having multiple of these monsters here, which is good. Okay. Okay, so Eetu's doing bachelor's and wow, okay. Well, your name sounds Finnish. Doesn't that mean that, I mean, I think many people do this kind of bachelor's and master's at the same time in Finland. Is that your plan, or do you plan to start it afterwards, or maybe not at all? Yeah, you okay, you do the master's. Yeah. And I don't know if that will happen to you, so uh, Mari, about the social aspect. So I can play games if I'm playing with somebody, because then it's kind of like the social atmosphere there. But if I would play alone something, then story is just not usually not strong enough to get me into it anymore. Okay, well, what's your thesis going to be about? If you graduate, then I guess you have your thesis decided. What is Eetu's thesis like? Okay, let's make. Okay, maybe this size of this monster. Nah. Okay, I'm gonna wrap it up. Let's just move these other things. Okay. Yeah. How about if the particles are going to move also with, yeah, I'm gonna add to this a random vector, and this random vector is going to be equal to x is gonna be something like math.random times maybe this radius, and y is going to be the same. So I'm going to have a random vector here, scaling it by the radius. If I do this and add it to the new location, then I'm going to get some jiggly behavior here. So this is going to be one-sided because this is a positive value. Let's make it balanced, so I could get between minus 0.5 and plus 0.5, and then scaled by the radius here somehow. Oh. Okay, I think I had enough, but yeah, okay, these are creepy, really creepy, but they are still interacting with my mouse pretty well. I wouldn't want to fight something like like this, so I think we are onto something. This game is gonna have quite interesting characters here. Yeah. Okay, that's it. So thanks guys for watching today. It was kind of fun to do this thing. I didn't know exactly what the result is going to be. I knew that I want something kind of like this, and I wanted to try this physics-based approach to get the movement a little bit more interesting. Okay. Aha. Well, I'm quite familiar with combinatorial optimization problems. So you want to use artificial intelligence, you want to use neural networks for that. Interesting. Okay. Well, in combinatorial optimization, you basically need to think what are the moves that are going to improve a solution from one state into another state. And if you want to use machine learning for this, then probably you are thinking about checking which moves were successful in the past, and then learning the features of these moves, the properties of these moves, and then your classifier or neural network in this case is going to hopefully apply these moves on unseen data, so on unseen combinatorial optimization problems. So basically, if I understand correctly, you want to train it by trying to optimize, seeing which moves are good, but having the computer learn these good moves and then doing them by itself in the future. Is it something like this, or am I totally off? Yeah, I would like to read that also. So good luck to get it published and out. I think it's an interesting topic, definitely. Yeah, so I'm wrapping this up. Okay, great. Well, good luck. Yeah, so again, cool. Yeah, great. I hope to see it. So that's it for today. I think thanks for watching, for tuning in, and hopefully you're also going to come next time and we get something even more interesting here. So see you guys.